welcome to another exciting episode of AP Chemistry here at Spain Park High School. Today is Friday, September the 29th. We're almost to the end of September, hallelujah, but it is Friday. Today we want to talk about what are the factors, what are the two things that determine how much dissolves, all right? Temperature and pressure. So when we look here at temperature, we have our three steps of our solution process. Delta H1 is solute-solute. Delta H2 is the solvent-solvent. Delta H3 is your solute-solvent. This is your lattice energy. This is the water attaching to your ions, and this is your water attaching to your covalent molecules. The attraction there, that hydration, the solvation of the solvent attaching to the solute. So when we look at this, we have to apply Le Chatelier's principle. Did we talk about this at all yesterday? Yes. Okay. What does Le Chatelier's principle say? If there's a stress, the reaction is going to do something to neutralize the stress. It's going to shift. It's always going to move away. So if we have an endothermic reaction like this one, where heat's being added to it, if you add heat, it's going to make more dissolve. If we have an exothermic, a negative heat of solution, heat's over here, so by adding heat, we're actually going to make things, the solute and the solvent, separate from one another. Most solids and liquids have a positive heat of solution. Now, if it's positive, which one of these three factors are endothermic processes? The solute-solute, the solvent-solvent, and or the solute-solvent. Which ones are endothermic? Which ones require energy? Okay, solvent-solvent is one. Again, remember, breaking up is always hard to do. Forming bonds always requires energy. Breaking bonds always requires energy. Forming bonds always releases energy. So which one of these are positive? Which ones are negative?
What's H1?
This is solute-solute, and it's all right there in your notes on the previous page. Solute-solute. This is solvent-solvent. And this is solute-solvent. Okay? Which ones are breaking bonds? Which ones are forming bonds?
H1 and H2 are breaking.
H1 and H2 are breaking. H3 is forming. Therefore, these two are you putting energy in to break a bond, or are you taking energy out to break a bond? Breaking up is always hard to do. It always requires energy. Endothermic reactions have a positive heat of solution. You put energy in to make it happen. When bonds form, energy is always released. So what's going to determine the overall sign of delta H of solution? What's going to determine the sign? Think simple math.
H3 relative to H1 plus H2.
The magnitude of H3, how big it is, it's negative, versus the magnitude of H1 and H2. These are both positive. Whichever, this sum versus this one, whichever one is bigger is going to determine the sign, right? 1 plus 1 plus a minus 3 is going to be minus 1. 1 plus 1 plus a minus 1 is going to be a plus 1. So what determines the overall sign is the magnitude of these values. Now we don't worry too much about delta H2. Delta H1, if it's an ionic compound, that's what we're going to refer to as the lattice energy. It's the energy needed to break the ions apart. That's what we're going to look at the most. Now if it's covalent, we're going to look at the strength of the IMFs holding them together. But most of the time we're dealing with an ionic compound dissolving in water. This energy, delta H3, is the water attaching to the solute. We refer to that as the energy of hydration. So you need to write that in your notes, delta H3. That's your energy of hydration. Energy of hydration. What does that mean? If something with a hydration, what does that mean?
Stretching.
Not water stretching. That's delta H2. Okay? The energy of hydration, and we know it's a negative value, right? It's the what? The bonding. Bonding of what?
Water and the salt.
The water and the solute. That Coulombic attraction between the positive end of water and the negative ion, the negative end of water and the positive ion, that attraction, that energy of hydration, when they come together, and we saw the video of the water coming in and attaching to the ion, pulling it into solution. Okay? That is your delta H3. This requires energy to break the ions apart. This releases energy. Now, generally, remember, it's going to be 2, 3, 4, 5, 6 water molecules attaching to a single ion. So it's kind of like, it's not like a one-to-one comparison, because there's a bunch of water coming in, ganging up and pulling those ions off of the crystal. But the overall magnitude of your delta H3 compared to this determines my overall delta H of solution. So most solids are endothermic. What does that mean about the lattice energy versus the energy of hydration? Which one's greater? Okay, simple math. If it's an endothermic reaction, what's the sign of delta H? We have to get that. What does endothermic mean? Reaction requires energy. If something requires energy, you don't take it out. Plus means add. So if it's a positive heat of solution, you're putting heat in to make the reaction occur. If it's a negative heat of solution, that means as the reaction occurs, heat is being released. So when paper burns in an exothermic reaction, this is the difference in energy. Well, where'd that energy go? To the surroundings. So the surroundings get hot. The products have less energy. Energy was removed from the system. This is the system. The reactants and the products is the system. The surroundings, then, the products have less potential energy. That energy has been released to the surroundings. Paper burns. We see the fire. Ice cube in your hand, the energy is going in to break the bonds of the ice, because you got to break bonds. It requires energy to melt the ice. So your hand feels cold because heat's leaving your hand going in to the ice cube. It's an endothermic reaction. So I come again. What's the sign of delta H if it's an endothermic reaction? Plus, positive. So if it's positive, this is positive, this is negative, which one has to be bigger? 1 or 3? 1. That's what determines the sign overall. If it's an exothermic reaction, which one's bigger? 1 or 3? 3. So the overall sign of delta H is determined if we have a positive heat solution. That means that the lattice energy is going to be greater than my energy of hydration. But if I have an exothermic, so like the sulfuric acid in water that we did, in that one, then that energy of hydration was greatly bigger than, in this case, the covalent bond holding the hydrogen to the chlorine, because that's what had to break. You had to, the sulfuric acid, the hydrogen from the sulfate. And so you had to break those ions apart, which was actually a covalent bond in that case. So the delta H1 was actually the bond energy between the oxygen and the hydrogen, because you had to make that hydrogen come off. But because it's so exothermic, I know that that energy of hydration must have been very high. Okay? So let's look at an AP question that would ask that. This is a multiple choice question off an old AP test. Okay? They actually give you the 3 steps of the solution process. The dissolution, and by the way, this word right here, the dissolution, that is AP's favorite fancy word. What do you think dissolution means? Even simpler. Dissolve. We could have said the dissolving of an ionic solute. Okay? But they use the word the dissolution. It means dissolving. Okay? The dissolution of an ionic solute in a polar solvent. So what do I know is going to be the attraction between the solute and the solvent? What's it going to be called? Okay? An ionic solute in a polar solvent. What's the attraction between the solute and the solvent called?
Is it like ion dipole?
That's not like ion dipole. It is ion dipole. Okay? It is ion to dipole attraction. So that ion to dipole is occurring in 3 steps shown above. In step 1, step 2, step 3. Which of the following best describes the enthalpy change for delta H for each step? Well, what did we just say? Delta H1. Are we breaking bonds or forming bonds?
Breaking.
So therefore it's going to be, what's the sign?
Minus.
Describes the enthalpy change delta H. Endo or exo?
Exo.
I know. I'm deleting this video, okay? We're not. Out of respect for the guilty, I'm deleting.
sure that everyone got it wrong.
I know, everybody did. I just spent 10 minutes going over it. And every single person said it wrong in unison. Help me, Jesus. Come on. Breaking bonds. Thank you. Step 2, the stretching of the solvent from solvent to allow space. Are you breaking a bond or forming a bond?
Breaking.
So therefore it is endo. Thank you. And then finally now, the attraction between the solute and the solvent, forming bonds, is exo. So what's my answer?
Plus, minus.
Which A, B, C, or D?
D.
D. Steps 1 and 2 are endo. Thank God it's Friday. Woo!